Hey there, so we're going to look at 10.6, the first problem set, number 31. So this is about solving systems of equations. And this is a nice one. This is a pretty tricky one. It was the only one that got nominated. So if you're stuck on any other ones, please let me know, and I'm happy to help you during class time over Zoom. Or we're going to, it seems like a tricky concept, so we're definitely going to spend some more time on it next Monday. So if you're stuck on it then, that's a really important, helpful Zoom class to show up for. Now for this one, we've got 5x and 3x, negative 9y and 7y. So none of them are ready to be canceled out, so that means we're going to multiply. None of these variables are also multiples of each other, so we're going to multiply both in this case. So I notice that I have the y's are at least positive and negative, so they're at least ready to be canceled out that way. So I'm going to make those two y's the same, and the easiest way to do that is just like with a common denominator. I'm going to multiply by the other so that they end up being the same. So the one with 9, I'm multiplying by 7. The one with 7, I'm multiplying by 9. So then I get 35x for the multiplying by 7 minus 63y is equal to 77. My second equation becomes 27x plus 63y is equal to 180 minus 9, 171. So now we have positive 63y, negative 63y. So those are ready to be canceled out. So I can just add my equations together. Those end up canceling. And I'm left with 35x plus 27x, which is that would be 62x is equal to 77 plus 171, which would be 248. Now I'm solving for x, so I'm going to divide by 62 on both sides. And hopefully I see here that x can be simplified by at least, we can start with 2. So I can say then x is equal to 124 over 31. These are nice because you can just divide each digit. And then I notice, 3 times 4 is 12, 1 times 4 is, 1 times 4 is 4. So with a little bit of deductive reasoning, 124 over 31 is 4. So that's our x value. Now these equations got a little bit complicated with larger numbers, so the nice thing is to find y, we can just plug it into that first one. So we can say 5x, x is 4, minus 9y equals 11. So then 20 minus 9y is equal to 11. Subtract 20 from both sides because 20 is positive. So I end up with negative 9y, because the negative is on the 9, not the 20, is equal to 11 minus 20 is also negative 9. So that when I divide both sides by negative 9, y by itself is equal to 1. So my final answer in an ordered pair, x is equal to 4, y is equal to 1. And there we go, that's my final answer. So this is definitely a tricky problem, and I'm really glad that students are nominating it. If you're stuck on any others, remember you can fill it out in the form, or again, I really encourage you to come to next Monday's Zoom class for your period, and the links are at the top of the classwork page. Talk to you later.